Alright, it's time for another math easy solution. We're going to discuss another problems plus example, and now look at example 6 of this video series, which deals with finding exactly one solution. Basically, problems plus are advanced problems that are in the back of each chapter of my calculus book, so I thought I might as well go over them at each chapter just to show, help illustrate each chapter better. So basically, this example I'm going to go over is, for what values of c does the equation ln x equals c x squared have exactly one solution? Well, first thing you should also do is graph this or draw it out just to see what it's exactly saying. And then basically what this is saying, you could also write it as for what values of c does the line y equals ln of x, and the second line, this one right here, the second function, y equals to cx squared, intersect only once. Intersect or touch only once. Basically, if the touches or intersects, that means that there's a solution to these two curves, that they touch each other. For example, basically if you have just any random function like this over here, and then this one over here, then if there's one solution, this only touches once exactly right here. There's one solution, and it's crossing in this case. But they can also touch by being tangent to it. So for example, if it's tangent, it doesn't need to cross, and there's a solution right over at this point right here. So now this is saying for how many, or for what values of c does the equation, this one here, have only one solution. So let's draw out first of all y equals ln of x. So if you were to draw the ln of x function, it looks something like this. So it would go down here. So basically it goes down to infinity here. It's not defined for less than 0 or x is less than 0. Then it just goes on like this curve over here. And now if you were, so this is ln of x, I'll just write ln of x right here. Now if you were to draw, basically there's three types of values c can be. Basically for c is greater than 0. So if we look at this one right here, when c is greater than 0, we're going to have, basically it's going to be positive, and it's going to be, the curve is going to be changed based on whatever c is. So it could be something like this. It would be just a parabola like that, like this, etc., like that. And also let's draw it more, basically more flat like this. As you can see in this case right here, this intersects twice, and if you go even flatter, we're gonna get something like this. You actually have something like this right here, where it intersects twice over here. It's supposed to be positive, just ignore my bad drawing. And as you can see, it's intersecting twice here. So so if it's intersecting twice, then that means there's two solutions for each curve, or these values of c right here. So this one right here, so we can't have two solutions. In this case, there is not intersecting at all. There is none. But there is at one value of c where it touches somewhere over here. So there is a tangent line over here. So inside this category, there is a c value. Now here I wrote it down here. For one c value which is greater than 0, this curve y equals cx squared is tangent to ln of x right here, which just means there's exactly one solution in this case. So we'll have to find that. We'll do that soon. But another type of c value is when c is equal to 0, another type of curve. This just becomes, well, y equals to 0. c is 0, 0 times x is 0. So it's going to be a horizontal line. That's just this x-axis. And this x-axis crosses once right over here, and that is exactly one solution. So there's one over here. And so these are two solutions. We don't want that. We only want one solution. And now the last part is when c is less than 0 right here. If you were to just draw it, it's going to be the same thing as this one, except it's going to be flipped upside down. So you're going to have curves like this, and you see it crosses once. It's going to go something like this, crosses once again if you make it more steep, crosses once over here. So there's once, once, once. So this is good. There's exactly one solution for each one. So then basically any value less than 0 or equal to 0, this would work for the answer. Basically, we'll be able to find exactly one solution. So the last thing we need to find is basically when it's tangent. So I'll graph this out just to make it a bit neater. So we need to find out the c value where it's tangent. So we'll just draw this out, tangent to it, pretend it's a better curve, and this would be basically cx squared. and we'll say it's tangent at this point right here. We'll call this a right here. So we need to find this value. Remember, when it's tangent, the derivatives match right here. So basically, if the derivatives match, because it's tangent line, so if you have y equals ln of x, the derivative is going to be y prime is equal to 1 over x. And now when we have the other one, y equals to cx squared, the derivative right here is going to be, well, y prime, to put the c down, I mean the 2 down, cx, using power rule. So we could do this. You can see proof of these derivatives in the video link below. So we have these ones right here, and they have to be the same because it's tangent right here, meaning the derivatives match right here, the slopes match. So basically at x equals to a, we get 1 over a is equal to 2ca right here. And now if we look at now basically basically just if we look at this curve right here, they both share at this point tangent line the same f of a function, or basically at this function they both have the same value. In other words, ln of a has to be equal to, plug in a inside this y function here, cx squared, ca squared right here. So we have this one right here. So we have two equations, this and this right here. We could rearrange this one, so then we can write this as, flip this, the 2 over here and the a over here. We'll get 1 over 2 is equal to ca squared. And the reason for this is so we could solve for what this a value is. And we could plug this in here. There's a ca squared, so that just equals 1 over 2. So we get ln a equals to 1 over 2 because that's ca squared, and there's ca squared, which is from this one. And now we have this. Now if we take it to the power of e on both sides, just so we can cancel the ln using logarithmic properties, this will be left with now a is equal to, so ln's cancel, ln and e cancels, e to the power 1 over 2. So we have a value for a right there. But we need to find the c value, and we could do that easily by plugging this over here. Well, we could also rearrange this, or rearrange this part right here for solving for c. So we get c is equal to 1 divided by 2a squared. Just move this a down there. So we know that c equals to 1 over 2a squared. Plug in this a. We're going to get 1 over 2e, 1 over 2, and I'll square it. All this is going to do is cancel out the squared, so we'll be left with c is equal to 1 over 2e. Yeah, so there is our other last c value. Thus, we have all the c values. And here, if we were to write it down here, I just typed it out to make it faster. Basically, thus ln x equals cx has only one solution, or intersect, or basically touch each other at only one point whenever c is less than or equal to 0, and c is equal to this one, 1 divided by 2e right here. And this is our final answer. Anyways, that is all for today. Hope you'll learn from this pretty useful example on how to use finding tangent line, also solutions of functions like this and the derivatives, etc. Anyways, you could download these exact notes in the link below, and thanks for watching, and stay tuned for another Math Easy solution.